So we're going to look at derivatives day 2, and we have to memorize some formulas. There's no way to figure them out. We just have to memorize them. So these are trig derivatives. Now the derivative of sine is cosine. That's real easy to remember. Derivative of tangent is secant squared. Derivative of secant is secant tangent. Now let's look at the bottom ones and tell me what you notice. What do you notice about every one of these? They're all negative. Now, what do all of these start with? They all start with a C. So the trig functions that start with C are cranky. They're negative. So if you take the derivative of something that starts with a C, the derivative is negative. I also want you to see I've written them in this order for a specific reason, trying to lessen how much you have to memorize. The derivative of sine is cosine. That's easy. That's, you know, sine and cosine. So the derivative of cosine is negative sine. Now, what about these? Here's the way I look at them. The derivative of tangent is secant squared. So then the derivative of cotangent is cosecant squared. See how these two are kind of the same thing? We just put cos on the bottom. The same thing over here. The derivative of secant is secant tangent. So the derivative of cosecant is negative because it's cranky, cosecant, cotangent. So I always felt like as a student, if I could write these two down, I would know these because I would just switch them to cos, right? It's less you have to, so to speak, memorize. You could write them down. Now you just got to keep these straight. Secret tan. I always think of secant as a secret. So secret tan, I don't know. Agent tangent is a secret. I don't know. Some crazy way that you can remember that, but we have to know that tangent goes with secant. Therefore, cotangent goes with cosecant. Okay, so this will be memory work. The one thing you want to know is that when you take the derivative of something that starts with a C, think C for cranky. Therefore, you must what? Put a negative sign in front, right? Where did the derivatives come from? Did somebody just make those up? No. So let's look for a second here. I already drew the graphs. So if you look at the graphs, this is cosine, right? And this is sine. And I told you the derivative of cosine of sine is cosine. And the word derivative means slope, correct? So if you look at sine right here, and it would keep going, what's the slope right here? Yeah, and it's 1, right? And what's the value of cosine? 1, because cosine is the slope of sine. If you look right here at sine, right? What is the value of sine? What is the derivative of sine right here? 0. And what's the value of cosine? 0. If you look right here, what's the slope of sine? -1. What's the value of cosine? -1. So does that make sense to you that these are not formulas somebody made up for the fun of it so you could memorize stuff? These came from the graphs, okay? None of us want to draw all these graphs and try to figure out slopes. So we're going to memorize those. What's the easiest way to memorize them? Write them down or make flashcards. One technique that I think is good is if you write them all down on some Post-it notes, and then you're like, okay, derivative of sine, well, that goes with cosine. Derivative of cosine, that goes negative sine. So you could take a minute. We don't have that many, right? There's only 6 of them for trig. So for all these derivatives that I need to have memorized for my test next class, I'd either use Post-it notes or flashcards, and I would write them and I'd mix them up and I'd match them up. Because what is your test? It's matching. So you'll have this piece and this piece, and you'll have to say, you know, number 1 goes with E or whatever. They'll be labeled A, B, C, D, E. So if you really want to study, do the ones we learned yesterday and the ones we learned today and make little flashcards. We'll have time today if you want to make them in class. That's the best way to study. Yes, ma'am. No, the test will be matching these 5 that we learned last time with these right here, these 10. So it'll be all the left side and you'll have to point to the right side that goes with it. Okay. Now that's going to be 15 questions. Then there'll be, so that's straight memory. Then there's 10 questions that will be trig problems where you have to say, you know, pi over 4 and 5 pi over 4, whatever the answer is. Okay. So 40% of the test, you're working the unit circle. 60% of the test is straight memory. Okay. And we'll practice once we're done here. All right. The other thing we need to memorize are exponential and logarithmic functions. That's straight memory. So if you look at this, the derivative of a to the x is simply a to the x. You just write what you see, and then the natural log of whatever that base is. Does that make sense? The derivative of e to the x is e to the x. That's our new favorite because it's so easy. What's the derivative of e to the x? E to the x. The derivative of the log base a of x, notice what happens. Y'all know that this little thing here is called the argument. The argument goes to the front and it's a natural log of the base. You see where the letters rearrange themselves, right? And then this, the natural log of x is 1 over x. So if I had the natural log of 8, the derivative would be 1/8. It's just 1 over this argument. Okay. That's like all the notes, but now we need to practice. It's going to take us a while to do a bunch of these to where you're like, okay. So I would have this out where I can see it, have your note sheet out where you can look at them. Because if you can do the work looking at these, then you know all you have to do is commit to memory. And after we do a bunch, you're already going to have a bunch memorized. And it will get easy and then we'll practice, right? You ready? Okay, let's go. All right. So some of these will be things we learned yesterday, and some of them are the new things we learned today. So find the derivative of each. So what is the derivative of x to the 6th? 6x to the 5th. And what does the word derivative mean? Slope. All right, let's see what we have memorized. What's the derivative of the square root of x? 1 over 2 root x, right? And what is the derivative of sine? Cosine. So we write 2 cosine x. We're done. You'll notice there's not a lot of arithmetic or math work for you to do. You got to go inside your head and pull out who that is. It's really memory work today. We'll make it more fun next time and put the thinking mix in with the memory, right? Okay, what about this? What is the derivative of 1 over x? Now remember, that's x to the 1st, right? So if you want to think about it, we know this is in the bottom, so it's going to change the sign. So it was positive, now it's negative. What is 1 times 1? 1, and now grow your x. It should now be squared because we go up by 1. Now remember also, derivatives power down, correct? I really want you to think about, like right here, the power went from 6 to 5, right? I want you to really keep in mind that derivatives power down, because later we're going to have to come back up and we want to make sure backwards and forwards don't get mixed up in our head. So, you know, you're finding the slope, the sleepy slope. So power down, go to sleep. No, don't really go to sleep. So derivatives power down. All right. What's the derivative of cosine? Sine. But cosine starts with a C. It's cranky. So it's going to change the sign This was a minus, so it's going to become a plus. Our coefficient stays there. Pi over 2 is kind of like 3/2, right? It's just a number. So pi over 2, cosine is sine. Not bad? You could do this. Y'all got it. All right, what about this guy? Derivative of 3x squared, 6x. Now, each thing separated by plus or minus signs, you just take the derivative of each term. Derivative of e to the x, e to the x. Derivative of tangent, secant squared x. Not bad? This is crazy good, right? Or see, not too much. Yeah. Absolutely. If ever I'm going too fast, you slow me right down. All righty. Are you ready? What do we do with this guy? Now, there's two ways to think about this. Let's look at both ways, and you choose the way that you're ready for. If I'm kind of advanced and I memorized everything from yesterday, I know that this is going to turn into what? It's going to turn into 2 root x on the bottom. I have a 4 on the top. So what's that really going to be? It's going to be 2. Minus, what's the derivative of secant? Secant, tangent. You could think you're seeking a tan, right? And what is the derivative of ln x? 1 over x. Now on this first guy, the square root, if square roots are a little bit hard for you yet because you're a beginner, is it okay to do this? Is it okay to say 4x to the 1/2? And now I could do my power rule. Half of 4 is 2x. 1/2 minus 1 is negative 1/2, which means 2 over the square root of x. If you need to rewrite square roots with powers so you can multiply and subtract, do that. Do what's going to get it done for you. As you do more and more of these, you'll get faster and you'll start to pick up on some of the patterns, and you will naturally start being able to do it with just your eyes, right? But don't miss a problem because you want to do it with your eyes. Slow and steady, the turtle wins the race, right? Okay, what about this? So this is a 3, yes. So we're going to say 3 times 2, correct? That's 6. Now, since that's in the bottom, what do I have to do with the sign in front? I have to take the opposite, right? And then I'm going to grow x to the 4th because it increases. Oh, what do I do with x to the 2/3? Bring the 2/3 to the front. And what's 2/3 minus 1? If you need to write that out here, how do I subtract 1? I say 3 over 3, right? I use my bottom. So that's negative 1/3 minus e to the x. What's the derivative of e to the x? E to the x. Now you might have to fix this one up, and that's okay. You can, how much paper are you allowed? Much as you want. You do not have to write small. And we'll fix that up. It's 2 on the top, 3 on the bottom. This guy has to go to the bottom because he has a negative exponent, and x to the 3rd is real, or 1/3 is really the cube root of x, right? Is that okay? All right, I'm going to give you a second. Now, these don't do anything different. So I'm going to give you a second to look at that. Okay, so what did you get for this little guy? 6x? plus 2 plus 2e to the x. And we're done, because what's the derivative of 19? 0, right? Okay, what about this guy now? I think these are easier if you put a little 1 down there, because that triggers you to say 1 times 2. So what is 1 times 2? Then I'm going to grow my bottom, yes. So what's the bottom now? X squared. Now, if I'm working with an exponent from the bottom, I have to change the sign out front, because it's really a negative that I multiply by. What is the derivative of x to the 7th? 7 x to the 6th. Now, I've got this one. Because it's the bottom, this sign is going to change, so it's going to be plus. What is 3 times 4? And I grow the bottom. Is that good? Do you feel like you're used to little x's in the bottom? That's not bad, right? You got it? All right, what does this mean? Evaluate the following derivative at the given value. That means find the derivative and then plug -3 in. That's not bad, right? So y prime equals 2x plus 5. Now I'm going to plug -3 in. 2 times -3 plus 5, -6 plus 5, -1. What does f prime of -3 mean? That means when x equals -3, the derivative, and what's a better word for derivative that's meaningful to us? The slope. The derivative or slope of the function y equals x squared plus 5x plus 3 is -1. So when you find the derivative and plug in a point, you know that when x is -3, the slope of this function is -1. Now, once we get to -4, it's going to change, right? Because it's a curve, not a line. True? All right, a few more and we'll be done. All right, this says find the first, second, and third derivatives. So what does that mean? Just keep on taking the derivatives. So I'm going to give you a minute to try those. Okay, so we do the first derivative. We have 5x to the 4th plus 9x squared minus 4. Did y'all get that? Y prime prime, meaning the second derivative, is 20x cubed plus 18x. Yes. And then y prime 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 is 20 times 3 is 60. Subtract 1 plus 18. Any trouble with polynomials? Those are easy, right? Now, what about this little critter? Derivative of e to the x? E to the x. Derivative of of ln x? 1 over x. Derivative of cosine? Negative sign, right? So this is already negative, so it's going to become plus. Now we'll take the derivative again. Derivative of e to the x. E to the x. Derivative of 1 over x. Well, x is in the bottom, so it's going to change the sign. And this is a 1, so 1 times 1 is 1. And grow. Everybody okay with those bottom ones? Hopefully everything will be simple and you won't have to work too hard, except maybe on radicals. And the derivative of sine? Yes, ma'am. Because this is really a -1. And if you brought it up to the top, you'd be multiplying. So anytime x is in the bottom, we're going to, because if I wrote it like this, right, I would do 1 times this, which would give me -1, x to the -2. So anytime we have an x down here that's growing in power, it will alternate the sign. Okay. Derivative of e to the x. Now this is in the bottom, so it's going to change my sign. I'm going to grow a power. And what's 2 times 1? 2. You got that system down? That's pretty good, right? And now the derivative of cosine. Negative sine. Not bad? Not too bad. Okay. We just have one more skill we want to hone in on, and then we can work. What is, find the tangent and normal line at the given point. Yeesh. All right. Okay. What do I do? What's the equation of a line? Whoops. Sorry. Y minus y1 equals m times x minus x1. Right? So I need an x and y point. I only have x. If you plug this in here, can you find y? Yes. So if x is 1, what does y equal? 5. Now I just need the slope. How does one go about finding a slope? No, we don't have a rise over run. We take the derivative. So the derivative is 10x. Basically, the slope equals 10x. Do you know what x is? Yes. The slope is 10. So now we can write the equation. It is y minus 5 equals 10 times x minus 1. And we're done. We do not want to move things around. Why do we not want to say 10x minus 10 and then bring the 5 over? Because let's think about this. This is a curve. It's a parabola, right? So the slope is only 10 at 1. So I want to leave it like this. That way I can say, hey, when x is 1 and y is 5, the slope is 10. Because if I switched x to 2, then I plug 2 in there, I'd have a different slope, right? So we're done with our tangent. What about this normal thing? What's the normal? Go back to physics for a minute. What's the normal force in physics? If you have an inclined plane, yes, it's gravity, right? This isn't going to move. It's being held to my arm by gravity. What is the force, though? What's the normal force in reference to the plane? No, easier than that. What shape? But what shape are these making? What angle? Right angle. The normal force is perpendicular, isn't it? So what is our normal line going to be? Perpendicular. So the numbers stay the same for x and y. But we have to take the perpendicular slope. So we flip it over and change its sign. So negative 1/10. See, you knew all that physics would pay off so you'd understand the normal force, right? All right. What next? Oh, same thing, but we have to put trig values in. So if you plug pi over 4 in here, what is tangent of pi over 4? One. So x is pi over 4, y is negative 3. Now we need the slope. So I got to take the derivative. What's the derivative of tangent? Secant squared. Okay, so this is my slope. I've got to plug pi over 4 in there. All right. I don't know secant of pi over 4, but I do know cosine of pi over 4. What is cosine of pi over 4? Root 2 over 2. So I have to flip that for secant. So what is root 2 over 2 flipped over? Which is just root 2. But it's squared. Remember, for trig, the value you get is what gets the square. So what's the square root of 2 squared? 2. So that's it, right? Not too bad. So what's that equation going to be? Y plus 3, because it's minus negative 3 equals negative 6. Oh, I ran out of room, times x minus pi over 4. Looks scary, but it's really not, right? What would the normal line be? Y plus 3. What is the opposite reciprocal of negative 6? 1/6. X minus pi over 4. The trig values are not going away. So study them if you've forgotten. All right, what about this? Find the tangent line at the given point. Okay, if x is e cubed, what is y? Well, what is the answer to ln e cubed? Remember, there's a little base e, and it's asking this little base e raised to what power is e cubed? So it's 3. In other words, if you have ln e to a power, that's your answer, if you've forgotten. Y equals 3. Now we've got to find the derivative. What is the derivative of ln x? 1 over x. So now I'll plug that in. So slope equals 1 over x was what? E cubed. So now we have x, we have y, we have the slope. Can we write the equation of a line? Yes, we can. See, now if I would have showed you that earlier, you would have thought it was scary, but it's not. If you need to take a minute and write some notes to yourself about what we did to help you remember, here, we'll take a minute. What do you think that means? Horizontal tangents. Find where the function has horizontal tangents. Not y? Yes, excellent work. When you see these instructions, your action is going to be to set derivative equal to 0. So first we take the derivative. What's the derivative of 2 sine x? 2 cosine x. 5 is just going to go away, right? So step 1, we found the derivative. Step 2, set it equal to 0. Okay, I could divide both sides by 2 and say 0 equals cosine x. At this point, I have to go into my brain and come up with that answer. Where does cosine equal x? Where does cosine equal 0? Pi over 2 and basically here and here, 3 pi over 2. So your trigonometry will not go away. All right, this one's easier. Y'all take a second and do that one. Okay, we take the derivative and we set it equal to 0. X equals 1. And it just says find where. So add x equals 1. The last question, find where the function has tangent lines parallel. What does that word tell you? What does parallel mean? Same slope. So it's parallel to this. What is the slope here? -1. So we're going to take the derivative and set it equal to -1. So what's the derivative of 3 cosine x? -3 sine x. And minus x, that's -1. Okay, there's our derivative. We'll set it equal to -1. So -3 sine x minus 1 equals -1. Add 1 to both sides. We have -3 sine x equals 0. We could divide both sides by -3, and sine x equals 0. Where does sine equal 0? Here and here. So we're going to call it 0 pi and pi. If you're given the choice whether to write 0 or 2 pi down, that's the same location. If you look at your homework in Delta Math, they're going to do this. Or they're going to write, they always write those instructions. I just forgot to put them in your notes. But don't write 2 pi and 0. If you state 0, 2 pi is the same location. You're just starting over again, right? Awesome. Wonderful job.